In this topic, we're going to cover classes, objects, and methods. So let's get started with object-oriented programming in Python by creating our own class for a person. To define a class, you first need to use the class keyword. So let's define our class person. We can save this. Classes, objects, methods.py. And inside the class, an init method can be defined to initialize an instance of the object. So in this case, the person object. And this method takes the self argument, which is a reference to the object itself. And this init constructor method is invoked automatically whenever a new object of the class is instantiated. So let's create that for our person class. Define __ init self. And when we instantiate a person, we're going to instantiate a person with a name and an age. And now we can define these instance attributes, self.name equals name and self.age equals age. And now that the person class is defined, we can create instances of that person. So let's create a person, Bob, who's of type person, and we pass in Bob's name and age. So we're creating an instance of the person class. Let's also create another person called Alice, who's 20, and a third person, Mallory, who's 50. And so now we can print out Bob, Alice, and Mallory. And we can see that we have our three separate person objects. And we can access information about these objects by using dot notation. So we could say print bob.name and print bob.age. And we can see here we have Bob's name and also his age. And we also have available to us class-specific functions which we can use to check whether or not attributes exist. So we could take a look whether or not Bob has the attribute age. We can also check whether he has the attribute ASD. And we can see that Bob does have the attribute age. However, Bob doesn't have the attribute ASD. And this is useful if you're not sure whether a specific attribute exists. And similar functions exist to check the object value as well. So we could have instead said print get attribute Bob age. We can run this again. And we can see here that we again have access to Bob's age. We can also set the attribute of an object. So we might want to give Bob ASD, give that the value of 100. And if the attribute does not exist, then it will be created. So now we could print out get attribute Bob ASD again. And now we can see that Bob has the attribute ASD, and we can see that it has the value of 100. And we can also delete this attribute from Bob. And now that it's deleted, if we try to access it again, we can see that we receive an attribute error here because the person object has no attribute ASD. And we're not constrained to using these default methods because we can also add additional functions to our object. So for example, we might want to have a function to print details about the person, such as their name or their age. And we can implement these as functions. So we can define a function print name, which takes self as a parameter. And we might say print my name is, and we'll use the format method. We can create another function, print underscore age self, and we can print out my age is. And we might want to also have another function called birthday, which will increase our age by 1. And now that these functions exist, we can also call them. So we could say bob.print name, alice.print name, and mallory.print name. We can now see my name is Bob, my name is Alice, my name is Mallory, and each object is calling the function with their own attributes. So Bob is printing out Bob, Alice is printing out Alice, and Mallory is printing out Mallory. And we can see the same thing if we use print age. And we can see the different ages for our different objects. And we can also change the values of public attributes. So we might say bob.age equals 31. And now we could say bob.print age again. And we can see that Bob's age has increased from 30 to 31. However, we can also use the birthday method, which we already implemented, to also increase Bob's age. So we could say bob.birthday, bob.print age. And we can see that calling bob.birthday has also increased Bob's age again by 1. And as well as these per instance variables, there are also class attributes. And class attributes are variables defined directly in the class and are shared by all objects of that class. So we can create a class attribute. So we might want to say wants to hack equals true. And now we can print out this class attribute, person.wants-to-hack. And we can see that this is true. And we can also access this attribute from instances of the class. So we can view it from Bob, and view it from Alice, and we can view it from Mallory. And changes made to the value of a class attribute change the value of that attribute for all instances of the class. So if we were to say person.wants-to-hack equals no way, and we then printed this out for the class and also the 3 instances that we have, save it first, we can see now that the class attribute now says no way instead of true. However, changing a class attribute value using an instance will not change the value for other instances. So for example, if we said bob.wants-to-hack equals yes way, and we printed this out again, copy and paste, we can see that person wants to hack is no way, Bob wants to hack is yes way, and Alice and Mallory both are no way too. And it's also possible to delete attributes, objects, or the entire class itself using the del keyword. So we might say del bob.name. And now if we try to print out Bob's name, we can see that we've printed out here, my name is Bob. Then we've deleted bob.name. And now when we try to call this function again, we receive an error because the person object has no attribute name. And we can similarly delete the person class. And we can try to print out alice.name. Let's comment this out first. And we can see that even though we deleted the class person, we can still access alice.name. However, if we try to create a new person, Bob2, who's 35, we can see that we receive a name error because the person class is no longer defined because we deleted it. And there are a number of special built-in class attributes associated with all Python classes. So we have access to person.dict, which is a dictionary containing the class's namespace. We also have access to doc, which is the class documentation string, or none if this isn't defined. We also have access to name, which is the class name. And we also have access to module, which is the module name in which the class is defined. So this attribute is main in interactive mode, which we talked about as part of the Python 101 for Hackers course. And so if we save and execute this, we can see the class's namespace dictionary, we can see the doc, we can see the class name, and we can see the module. And we can also change some of these attributes. So for example, instead of printing out none here, we might want to print out person base class. And now we can execute this again. And we can see that the class documentation string now prints out person base class instead of none. And object-oriented programming is really useful because it enables you to create a class and then reuse it. If you need to change something about a class, it's easier doing this centrally rather than needing to search, find, change, and copy and paste code throughout your program. But that's it for now. And in the next lesson, we are going to cover inheritance.